Okay, this is Angles of Elevation and Depression, Chapter 8, Section 4. This is going to be a relatively quick talk. So, angle of elevation. If you notice in the picture, there's a young lady in the lower left-hand corner, and she is looking up at somebody in a hang glider. Since she is looking up, we call that elevation or angle of elevation, and she is looking up at an angle of 38 degrees. Likewise, if you look at the person in the hang glider, he is looking down at the young lady and looking down at the young lady also at an angle of 38 degrees. Notice that the young lady is looking, her line of sight is looking in the horizontal direction, and the hang glider's line of sight is also looking in the horizontal direction. If you recall, horizontal lines are parallel, so these two lines are parallel, and if you look at the line between the young lady and the hang glider, it forms a diagonal. We have a diagonal cutting across two parallel lines. So that means that it's a transversal. Sounds a little familiar. We have a transversal cutting across two parallel lines, which means that both those angles are the same, and they have to be the same because they are alternate interior angles. We notice that the diagonal is inside of the two horizontal lines, and the hang glider is looking down at 38, and she's looking up at 38. They're alternate interior angles, so they are congruent. They are the same. So if they are looking at each other, the angle of depression and the angle of elevation will be identical. In this photo, we have somebody in a blimp looking up at a bird and looking down at the bottom of a mountain. And if we look at the bird looking down on the person in the blimp, since the person is looking down, we would call that an angle of depression. Angle number 2, the person is looking up at the bird. Since the person is looking up, we call that an angle of elevation. And notice that the angle 1 and angle 2 are also congruent because that line between the bird and the blimp and the person in the blimp is cutting across those two parallel lines. If we look at angle 3, looking down upon the base of the mountain, since it's looking down, it is an angle of depression. And if the angle from the base of the mountain going up to the person in the blimp, since it's going up, angle 4 would be also angle of elevation. And like I said with the previous two, angle 3 and angle 4 are congruent. They're the same because they're alternating interior angles. There's only going to be one problem associated with this talk today, and it's going to be this one. It's also from an example in your book. You cite a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground. That's important. And you are 1,000 feet away from the base of the cliff. What is the approximate height of the rock climber from the ground? So, you're at the eye level. The part that says eye level is you. You are 6 feet above the ground. So the eye level isn't you. The eye level is you 6 feet above the ground. You are 1,000 feet away from the mountain or the cliff, and the climber is at the top of the triangle on the right hand side, top of the cliff, and you're looking at the climber, and the climber is probably looking at you. You're looking at the climber at a 32-degree angle. So we'll say the distance from your eye level to the climber, we're going to call that distance x. And notice that that distance x, or the climber, that distance is opposite of you, opposite of the eye level. Since you're looking up at the climber, this is an angle of elevation, and the angle of elevation is 32 degrees. Since the climber is opposite of that 32-degree angle, that's a big clue as to which type of trigonometric ratio we're going to use. The cliff is 1,000 feet away from the eye level, or from your eye level. Notice that the 1,000 feet is adjacent. It touches that 32 degrees, and it's also not the hypotenuse. So it's an adjacent leg to the eye level. So we have opposite, we have adjacent, which means that it's probably going to be using our SOHCAHTOA, opposite over adjacent, tangent. So when we set up the equation, it's going to be tangent of 32 degrees, because that's your angle of elevation, is equal to opposite, which is x, over adjacent, which is 1,000. We multiply both sides by 1,000, and we get that x, the distance between the eye level and the climber, is 1,000 times the tangent of 32 degrees. Please make sure that your calculator is set to degrees. And you get that the distance from the eye level to the climber is about 624.8 feet. But that's not what they want. The problem says the distance from the rock climber to the ground. You are an additional 6 feet. So we're going to add that additional 6 feet between your eye level and the ground, and the eye level and the climber, and it's going to be 624.8 plus 6, which will give us about 630.8 feet, which rounds out to about 631 feet. So that is the height of our cliff. And that's our talk on section 8-4. Have a great day, guys.